Hey there, Seahawks. It's Miss Adams, and in this video, we're going to talk about regression wisdom and transforming data. All right, so outliers and scatter plots. An outlier is a data point that has a very large residual when we're talking about linear regression and lines of best fit. A leverage point is when the data point has a x value that is far from the mean of the other x values. So if it's very far off in the x direction, then it's most likely a leverage point. Typically, a leverage point will be in line with all your other data values. So it kind of strengthens the slope. Okay. If it is not in line with the other data values and it greatly impacts the slope, then it's an influential point. Okay, so an influential point greatly changes the slope. So if you omit that data value and the regression analysis changes a lot, then that point would be influential. All right, lurking variables. A hidden variable that can explain both the explanatory and response variables. So an example is the more firemen that you have in a house, the more damage that you have in the house. Do firemen cause the damage? Well, no. Okay, there's most likely a lurking variable here, and the lurking variable may be the size and severity of the fire. Okay, so the worse the fire is, the more firemen it's going to take to put it out. All right, so achieving linearity. If you put in a data set and you look at the scatter plot and it definitely does not meet that straight enough condition. Okay, so there's several things that we can do to linearize the data. Okay, this is more of like the old school method that we used to do. So your standard linear regression is y equals b sub o plus b sub 1x. Okay, and then our predicted equations follows that same model. An exponential model, we would take the log of our y values. Okay, and then we'd have to, when we write the equation, we'd have to undo the log by raising everything like a base of 10. Quadratic, we would square root all the y values. Reciprocal model, logarithmic model, we'd take the log of the x values. Power model, we do the log of the x and log of the y. And anywhere where you're doing log, you could also do natural log instead. Okay, so old school method, we used to actually take our lists and then we'd make a new list. So let's say we had list 1 and list 2. Then we'd make new list 3. In list 3, we'd do the log of all of the values in list 1, all of your x values. List 4, we'd do a log of all of the y values. So you just go up to the top and press log of list 2, and it'll give you the log of all of those values. And then you would do stat calc 8, so the linear regression, with those logged values. Okay, so if it was exponential, you'd just use the log of the y's. If it was power, you'd do log of both. So typically, the ones that we focus on, especially for the AP exam, are the exponential model and the power model. So you want to start with those. Okay, and then you would substitute log or natural log to make your new list. However, things have been updated. Calculators have a little bit more functionality. So your calculator, for the most part, can do the exponential regression or the power regression or even the quadratic regression. It has several different regression models depending on the age of your calculator and the operating system. So we are going to kind of go through this list. This is a little bit more of the old school method. And then we're going to go through and show you a little bit of both of those on the calculator. So steps to transformation. Transforming a data set to enhance linearity is a multi-step trial and error process. Conduct a standard regression analysis on the raw data. So stat calc 8. Look at the scatter plot. All right. Then construct a residual plot. If the plot pattern is normal, okay, so it's just a scattered mess, there's nothing unusual there, then don't transform your data. If the pattern, or if the residual plot has a pattern or a curve, then you're going to want to look at the R-squared value when you did the original regression analysis. So for linear regression, what was your R-squared? Okay, choose a transformation method. So you might want to look at the original scatter plot and see kind of if you know what fits based on what the graph looks like. Okay. And then transform your independent variable or your dependent variable or both. So square root, take the log of your x values, square root, take the log of your y values, whatever it is. And then do another regression analysis, so stat calc 8, using those new lists, okay, those transformed lists. And then look at the R-squared value. If the R-squared value went up, okay, it is closer to 1, then it most likely made an impact. But you're still going to want to look at the residual plot of your new residuals and see if there's an obvious pattern or curve. All right. If that didn't work, try a different transformation method until you find something that has a nice residual plot and a nicer R-squared value. Keep in mind, it may not always be a perfect residual plot. You're looking for no obvious, very, very obvious, like striking patterns or curves, okay? All right, so here is some data. Okay, so this data I've gone ahead and put into my calculator. So stat edit, I put the year as year since 1900. So 1971, I just put in a 71 because otherwise the values were kind of too large for my calculator. And so if you go and you do stat calc 8, do a linear regression, list 1, list 2, we're going to go ahead and actually have it draw my regression equation. So I'm going to go to vars, y-vars, functions, y1. So it's going to graph that line of best fit there for me. Calculate. Okay, and if you notice, our R-squared value, our coefficient of determination, is only 0.5. So that's not very strong. Okay, so that would tell us that this maybe is not a good model already. If we go and look at the scatter plot, I'm going to look at the scatter plot of just my list 1, list 2. So zoom 9. You can see that there is something going on here. This does not meet the straight enough condition. And when I draw my line of best fit, it definitely is not the line of best fit to match this data. Okay, so I'm going to use my calculator, stat calc. It looked to be like it was maybe an exponential trend going on there. So stat calc, and I'm going to look through this list at some of my different regression equations that I have. And I have an exponential regression. So I'm going to use that. List 1, list 2, and I'm going to tell it to store my new equation here. So vars, y-vars, functions, y1. Calculate it, see if we get a better R-squared. So our R-squared now is 0.99, much, much better. So that can kind of tell us that we have probably a better model. And then if I go and look at my scatter plot, okay, the scatter plot is going to look the same. I didn't change the data at all, but that line of best fit I stored in there. So let's see if that kind of fits to the data better. So it's taking a little while to draw this one, but you can see that it does definitely map to the data a lot better. Okay. And then if we look at the residual plot, so I'm going to change list 2 to my residuals. So this is the residual plot using the exponential regression. Okay, these points are a little bit off here, but for the most part, there seems like it's very small residuals, but in fact, it's actually just this, the residuals are very large and it's just very zoomed out a lot. So it's kind of hard to tell how spread out these are because of the very, very large values that we're working with here. let me go back and show you what the original scatter plot, when you did just a linear regression, because we didn't look at that, and see how much worse that one was. So stat plot, residuals, 9. So that was the original residual plot. And so after I did the exponential regression, that residual plot was much, much nicer. Okay, if you're going to do it the old school method, you go to stat, edit, go up here, list 3. You would want to go and you would want to take the log of all your list 1 values. So make sure you go up top, highlight list 3, and then type log of list 1. Enter, and it'll give you all of this list is now the log of all your list 1 values. List 4, go up there and create the log of, the log of list 2. And now you have the log of all your list 2 values. And you could use that. One other thing I want to show you, so stat calc, when you do an exponential regression, it actually gives you all those pieces to write your equation without having to go back and undo the log and do all the algebra pieces. So it gives you A and B, but notice it's not A plus BX. This is A times B to the X power. And if you had picked a different model, like maybe the power model, it would give you this formula and A and B, and it would be a different formula. All right, so that's pretty much it.